क्या भैया? अच्छा, मैं भूल गया था, रुक जा 1 मिनट। क्या केमिकल का नाम क्या बताई? नहीं।
E é para massa, hecha. Mas fatta na mão. Care boxe de la
Bună dimineața, vă rog să vă opriți microfoanele.
Bună dimineața, opresc acum.
Foarte singur.
Vrei să-l dați mai încet de aici, da? Că până începe la 9. Să nu deranjeze pe de ea.
Nu.
Da, uite, tata, și apeși pe ăsta când vrei să ieși.
Care?
Deci, stai părăsiți.
Unde?
Uite aici.
Everybody, and welcome to the second day of our international event, EMERGEMAT 2025. For the first announcement of the day, I will remind all the participants the sponsors of our event. It is about the Romanian Ministry of Education and Research, the European Technology Platform on Sustainable Mineral Resources, and two Romanian companies, Nanoteam and Altium. Once again, thank you to our sponsors. Yes, and the European platform is also co-organizer, and we thank for the support with the online communication with all our participants. Coming back to the presentation of the second day, I have the pleasure to invite Mrs. Catarina Quist from EPIROC, European Technology Platform of Sustainable Mineral Resources. Mrs. Quist, if you can hear us, I know that you are online. You are welcome to share your presentation and proceed with it.
Okay, you want me to share the presentation. Thank you. I will do that straight away. So let's see. So let's see, do you start to see something?
Yes, we can see it, but
Perfect.
if you try to
I will go
use
into presentation.
Yes, perfect, great.
So, okay, and you can hear me clearly. Good. Good. So my name is Katarina, so thank you for inviting me. And I'm also a member of the ExCom for the ETP-SMR. So we will talk about strategic alignment of sustainable metallurgy and material substitution, and how this connects to ETP-SMR and our strategic agenda for critical raw materials. So just first, what is ETP-SMR? It stands for European Technology Platform on Sustainable Mineral Resources, and it's an association of entities operating in the mineral resources and area sector across the whole value chain. Do you think you maybe can, there is somebody on the line? So thank you. So it's the whole value chain of minerals and metals. So it contains companies and organizations and academia from exploration, mining, mineral processing, refining, and recycling. And the mission is to develop a long-term European minerals and industries research agendas for roadmaps for actions, both on EU level, national level, and I would also say actually global level, fostering a resilient and sustainable raw material sectors. The key objectives is to promote cutting-edge research, development, and innovation within the mineral resource value chain, and define strategic roadmaps for impactful actions across Europe, strengthening the competitiveness and sustainability of European mining and mineral industries. These are the members that are inside ETPSMR for the moment. We are still a growing organization covering the majority of Europe, and we can also look into to see who are these organizations. And here you can see we are covering the raw material industry, technology providers, geological surveys, academia and research institutes, industry and stakeholders association, and international partner also. And you can also see the split here to the right. So it's quite heavy on academia and industry for the moment, but we try to have a balanced way of looking into the membership and the partnership here, trying to cover the whole perspective of what we need in to look for challenges and how we will be successful. The tool, I think the biggest tool we have is our strategic research innovation agenda. And it's also, we work with this more or less, we update it every second to third to fourth year. And it's what I think is important is actually the work, how we do this. And this is then combining the whole sector, and the members are working together to finalize and update an agenda like this. It actually makes us look into different kind of perspective on the challenges and how we can reach a success. It's built on 10 strategic areas. So exploration and resource characterization, the mining, mineral processing, metallurgy and metallurgy recovery and recycling, decarbonization of the operations, forecast and substitutions of raw materials, environmental performance, social performance, raw materials policy and monitoring, and global partnership. This is how we build the strategic agenda on. And then we use this strategic agenda. What we are doing exactly now for the moment is building a strategic implementation plan. And this is built on different type of activities we need to do to drive the implementation, strategic updates, securing funding. This is the communication to the European Commission and the programs that they are running and the other tools they are running to see that we really can contribute with funding to the activities we need to do. Goal alignment, of course, with the European Commission goals and also other type of organizations and industries. The CRM relevance to maintain a strong connection to the CRM communities to ensure that our program remain relevant to current EU raw material policy. So we use this one also then to have an impact on call topics, objectives, scopes, budgets, expected outcome, and also type of calls that the Commission will form. And then we come into a little bit more today where you are. Strategic metallurgy, aligning this agenda for critical raw materials, materials sustainability, extreme condition, and their performance. Can you still hear me? I'm just wondering because it's blipping a lot. Yes, am I still on? Yeah. Okay. Great. Yes. Great. I can't. Okay, perfect, because I can't see you really. Okay, we go on to this slide then, coming a little bit more into your depth. So the European Union faces significant strategic challenges concerning the supply and processing of critical raw materials and the vulnerability that impacts its ambition for technology sovereignty and the socio-economic transition. The Critical Raw Materials Act establish and quantify benchmarks for domestic extraction, processing capacity, demanding on comprehensive, coordinating research and innovation response. And this will then fall into how the agenda again is built on different kind of strategic pillars. So this RIA is developed by the ETPSMR, serves a direct collaborative policy instrument designed to address these benchmarks. And RIA core strategy goals are centered on raising the competitiveness of European raw material sector through innovation, stimulating the commercialization of the research results, and ultimately improving self-sufficient in the raw material supply. Then we're coming into the 4 pillars. The strategic 4 pillars and ambitions of this RIA 2023 supports the development of new materials and process for sustainable embedding of critical raw materials for extreme condition. Explicitly, it's designed to contribute and secure the supply of primary and secondary mineral raw materials, strengthening the supply chain, fostering resource efficiency, while simultaneously addressing the environmental and social impacts. Its central strategic pillars establish the framework for innovation across the value chain. And if you look more closely then into the pillars, if you look at the first one, this RIA emphasizes raising the competitiveness for the sector and the commercialization of research results. So for extreme conditions, this ensures that specialized high TRL level materials research can transition effectively into industrial products, securing European intellectual property and reducing the reliance on external technology. If you look at the second pillar, supply security and diversification, strategy focus is on improving self-sufficiency in European raw material supply and enabling diversification through the deployment of new technologies. So this is critical for the high-value niche of the CRMs, where supply disruption presents an existential risks to strategic European industries, such as aerospace and defense, for example. Looking into 3, industrial technological leadership. The ambition is to gain industrial and technology leadership in core segments of the value chain. And this leadership must extend beyond extraction to encompass advanced processing techniques and high-performance materials formulation, which are prerequisite for material qualified for extreme condition use. Coming into the 4th, the efficiency. The strategic imperative of raising resources and energy efficiency serves a dual role. It lowers the operational cost associated with complex mineral processing, while ensuring adherence to stringent European climate goals. Then coming into the vision for sort of sustainable processing and zero waste, you can see that we are working with this RIA to highly efficient and to improve circular and low impact metallurgy processes to supply and secure supply, and also of course then do it by capacity increase, clean technology, circularity, and secondary sources. This conference that you are on today, the theme there emphasizes the development of sustainable processes for embedding CRMs, a concept directly addressed by the RIA and the ambition roadmap for metallurgy. The pursuit of a zero waste metallurgy infrastructure implies the mastery of a highly efficient, precise separation and refining technologies. This technical precision is essential for environmental goals, but also directly enables the high material quality necessary for extreme application. Material operating under extreme and thermal mechanical stress, such as those used in gas turbines or plasma-facing components, are exceptionally sensitive to trace impurities, and the impurities, even as a parts per million level, can lead to really catastrophe and defects that has a real impact on failure points under high stress or temperature exposure. Therefore, the technology advances necessary for sustainability are the same advances that provide the superior material purity required for predictable reliability and structural integrity in extreme environments. And sustainable processing in the linked to achieving the technical quality standards necessary for predictable high performance embedding. So I think this is critically important. Then coming into the integration of CRMs into modern high technology applications frequently requires also materials capable of functioning reliability under extreme conditions. These conditions are technically defined by environments involving continuously sustained exposure to high temperature, intense mechanical stresses, corrosive chemical media, or serve radiation fluxes. So material engineers for these demanding environments must exhibit the performance far superior to standard commercial grades, demanding characteristics such as exceptional creep resistance, high strength to weight ratios, and predictable fatigue life and chemical internals. The necessity for predictable performance directly translates into the SRIA strategic goals of achieving material substitutions that contributes to enhanced durability. The traditional supply chain model is demonstrably insufficient not only in the terms of supply volume, but also critically in the capacity to deliver ultra-high purity and quality specifications required for predictable performance under high stress. Consequently, addressing the CRM supply risk for these high-stakes applications requires a fundamental shift in both material development, process technology, and emphasizing performance, safety, and lifespan, which are defining characteristics of material engineering for extreme environments. And this is something I can underline as coming from an equipment company. Their resilience and robustness is a key for going further on with automation, for example. We can't have components and parts not performing on the level we need to when we are trying to go autonomous. This is something I can actually very much sign. Strategy of substitution and hence durability. The ETP-SMR agenda really champions material substitution as a mechanism to reduce criticality of CRMs. However, in reality of extreme conditions, substitution is a complex and high-risk proposition. Materials R&D for high-performance application operates under extremely strict qualification standards, as failure can be catastrophic. The challenge is not simply finding a material that can replace a CRM-dependent component, but finding one that actually can maintain or ideally exceed the proven performance and lifespan of the original material. This demands a massive coordinated effort spanning material science, mechanical engineering, and a non-destructive testing. This is critical. Enabling technology leaps through advanced metallurgy. The SRIA recognize that achieving strategic materials goals requires fundamental advancement in the European processing base. It calls for European smelters to make more important technology leaps that contributes directly to the raw material security of CRMs and SRMs. Public-private partnerships, such as those facilitated by ETP-SMR, are essential for underwriting the risky low-cycle development required for qualifying new materials for extreme environment applications. This strategic alignment ensures that research and innovation funding are prioritized projects that demonstrably achieve both resources efficiency and the target metric of enhanced durability. Strategic linkage between the ETP-SMR and the development of materials for extreme condition reveals a cohesive European strategy. Sustainable embedding is achieved through multi-phased approach defined by intersections of resource efficiency and high performance engineers. And it then covers the secure supply, sustainability, performance, and knowledge-based. Coming to the end, the agenda serves as a critical strategic framework for advancing material solutions necessary for the EU green and digital transitions, including highly demanding sectors for extreme condition materials. Although SRIA does not explicitly use the term extreme condition, it is robustly addressed and the technical requirements through its explicit ambition for material substitution, leading to enhanced durability and commitment to zero waste methodology. The successful implementation of this agenda will secure European technology leadership by providing domestic capacity for sourcing, processing, validation of the next generation of high purity, sustainable raw material required for strategic, high-performance application. So this, of course, calls to an action that we need a prioritized, integrated research and innovation agenda with projects. We also need to see that we can sustain investment for critical research infrastructure and specialized workforce required for the next generation of material development. So I'm coming to the end. So I wonder if there are any questions or in the room or maybe online. So this was the presentation from ETP-SMR.
Mrs. Quist for the interesting presentation. If there are
Thank you.
questions from the hall or online questions.
Good morning. My name is Radu Piticescu. Thank you for the presentation. It's very interesting. And I would like to know how we can be more our work can be more recognized at European level. For example, starting with next year, our institute will be part of a new center of excellence, national center of excellence in the field of materials for extreme conditions. And we are really interested to promote our work and to make to develop partnership with possible enterprises, with possible institutes and academia that can enhance our work in the future.
Yeah,
This project,
I think.
Yes.
Yes, I think there are many ways to do that. And we'll be happy to contribute because I think this is coming also into the interesting thing here is this, the cross collaboration needed. So we need the expertise like you coming into how do we develop the material to perform in the right condition and also maybe do the exchange of a critical raw material to something else. This work also need to be cross collaborative to the applications. And this, for example, where, sorry? Sorry, we have more voices in the room.
People from online, turn off your microphones, please. Thank you. From online, please turn off your microphones.
So
Sorry,
coming back
Mrs.
to,
Quist.
yeah,
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 please.
thank you. That's the way it is when you are doing a combination hybrid event.
Once,
So
once again, the last
yeah.
sentence, please. Sorry.
Yes, so I think there are many ways to answer your question. There are many ways to sort of come in and enter, and I think it's critical that we reach all the type of research that is done that can contribute to what we need to do here. And also I think when we were wrapped it, I tried to say that it's not just the research as such, it's also the application, the link to the application, the cross-collaborative need that's going to be sort of also needed to do this transition that we are in the phase of doing. All of us is working for the green transition and how we can manage it. But I think a simple thing could be like to join different kind of networks like the ETP-SMR to, from the Romanian side, see that you are connected, and also then to connect you to different kind of university levels, to be also active in European projects. To join there, that's a very good way of exchanging research and also sort of contributing with results and work collaborative. I think that's a very good example. So we have this Horizon program. This is one of the parts that the ETP-SMR are working to have an impact on, and to try to say this is what the industries, this is what the researchers need, the funding for running different kind of projects and activities. So I think to come into the European community and try to join different kind of levels of activities like the ETP-SMR is one. That's more like a lobby organization, but here you will meet as you saw on the membership, it's academia, it's researcher, but it's more about what kind of elements do we need to accelerate this one. And then you have the Raw Materials Week is a good way also to come in contact with different kind of researchers, but also organizations that can have a use for your research. And also the program as such, applying to the Horizon program together with other partners. Was that good answer enough? Maybe practical one, but...
Okay, thank you very much. It is indeed, I think it's an opportunity for us to be more active
Yes, it
in
is.
the platform. Okay, thank you very much.
Yes, absolutely. So take the opportunity and try to connect to the Excellence Center, but also, as I said, to like the Raw Material Week and other types of activities that is done inside Europe and the projects. You have also EIT Raw Materials. That is also a network and a platform that you can connect to, where you have also a number of different kind of partnerships and types of organizations, everything from industry down to research organizations and academia. So that could also be a good platform to look into to see.
Okay, thank you once again, Mrs. Quist.
Thank you, and I
Any
wish
other
you all,
questions?
I wish you all a nice day and a very good conference.
Thank you, and also thank you
Yeah,
for
and I
your
hope I see
help
you
and for
in
the
Brussels
presentation.
yeah, and I hope I see you all in Brussels in December.
Let's
Take care,
hope.
everyone. Bye
Thank
bye.
you. Bye. Thank you. So right now we will continue with the presentations in the frame of section 3, which is co-chaired by Dr. Mochoiu and Dr. Simeon. I will give them the floor. So
Thank you. Good morning and welcome to the second day of our conference. Mr. Cristian Simeon and I will continue the section 3 for yesterday. Is online?
We cannot hear you, Mr. Simeon.
He is unmuted. Christian, can you say something?
Okay.
Or can you text in the chat whether you can hear us?
I think he can hear us, but his microphone is not working.
Screen.
Yes, but we cannot hear you. It seems like your microphone is unmuted, but it's not working.
Please make sure that you use the right settings.
Okay,
Maybe we
we
can
go
start.
further and okay, in this case, our first presentation from today is from Portugal, Mr. Pedro Pereira from University of Aveiro. Mr. Pereira, if you are online, please, the floor is
Good morning.
yours.
I'm here. Thank you.
Morning.
Let me share my presentation. Can you see my presentation?
Yes,
Yes.
we can see it.
Okay, thank you very much. Okay, so I'll start now. So I really love burgers. Probably many of you do too, but there is a problem. This is not sustainable. So I'm João Pedro Correia from the University of Aveiro. I'm a research fellow under the Feed Value Project, and I'm here today to present you a way how to convert agri-food waste into value porous materials, aiming to reduce waste, aiming to reduce greenhouse emissions from ruminants. So, as you can see, each cow emits almost 4.9 tons of CO2 equivalent, and every year. And one of the gases that the cows emit is methane, and methane can be like 28 times more potent than CO2. And livestock is responsible for about 14.5% of total greenhouse emissions. So we need to innovate. We need sustainable solutions for this. So our approach in our project, it's try to use bio-based materials derived from food waste, in this case, apple pomace. In the industry, we produce annually approximately 20 millions of tons every year. So we can try to give a new life to these kinds of products. So the material we need to produce is a carbonaceous material like biochar or activate carbon. And the material must be safe for ingestion, non-toxic, and efficient in absorbing methane and CO2 inside the rumen of the cows. First, we start with the apple pomace fertilization with a TGA. As you can see, in nitrogen, the graph shows a different behavior of in the air. So in nitrogen, the sample retains more mass, while in the air it runs out completely, leaving just 0.43% of residue. This proves the organic rich nature of this feedstock. That's what we want. In the elemental analysis, so we can see like a high tier of carbon. That's what we want. And we have no sulfur. That's very good for the feed supplements. The increase in carbon confirms the material suitability for porous carbon production. So our methodology. First, the apple pomace was dried, mainly ground, and paralyzed at different temperatures and durations, between 1500 and 1600 degrees, and we try to go to 80 to 100 degrees too. Between 30 to 60 minutes, and the AT ramp was controlled, resulting in the base material that as you can see, the biochar. First, we did the characterization, textural characterization in the biochar produced. As you can see, depending on the temperature, even at higher temperatures, we have a low specific surface area and low micropore volume. We try 80, 100 degrees, but the results were not so good. So we need to arrange another way. In this image of the SEM microscope, as you can see the sample of 800 degrees 1 hour, we can see like a not so porous material. That we don't want this. We want a porous material, more porous material. So we need to try arrange a way to improve this surface area. So here we can see our approach for this. It was activated, the carbon, the biochar. In this case, a physical activation with CO2 gas or steam vapor. So we perform physical activation using CO2 or steam. The temperatures between 700 degrees and 800 degrees for 20 to 120 minutes. This was done after pyrolysis to change porosity and surface area, but in one way only. So the pyrolysis and the activation was done in one step to try to optimize the energy and efficiency. As you can see here, we have example of our reactor. So we have the gas selection valve. When you can select the gas or CO2 or N2, and there you have our steam machine. So in here you can see like a different results as more the close that we want, a bigger specific surface area, more micropore volume, and the Paris yield was very similar between the samples, but at higher temperature and higher time, we had a much bigger specific surface area. In here, the samples activated with steam, we have a little bit of different behavior. So as you can see, at lower temperatures between 700 and 750, we have similar pyrolysis and specific surface area and power volume very similar too, and not so high. The thing change when you go to higher temperature, like 750 degrees. We have a more increase in the specific surface area and in the micropore volume too. But that's interesting that we have a similar results between the 750 sample and the 800 degrees. With less temperature and the same time, activated time, we have similar specific surface area. And that's very interesting results for us. In here, as you can see, the same images, comparison. In the middle, we have our reference, the biochar, 800 degrees 1 hour, and our left, we have the samples activated, two examples of samples activated with CO2, and our right, two examples of our samples activated with H2O. We have different porosities in comparison with the middle, and a little bit of different morphology in the samples activated with H2O. This is our first adsorption test with the sample with the biggest specific surface area. So the sample 800 degrees 2 hours CO2. And as you can see, we have adsorption in the CO2 and with methane too. With the CO2, we have like almost the double of the adsorption in comparison with methane. That's very good. So you can show, I show you the potential of our samples to absorb gases. In conclusion, so SIM activation is more efficient in terms of energy and yield. With lesser time, we had a good results in the surface area microporosity. So water vapor showed greater activation efficiency than CO2, and it's more environment friendly, I can say that. We had high surface areas, so bigger than 600 meters per gram, and micropore volumes, good micropore volume were achieved. And these materials are promising for CH4 and CO2 absorption in the human. In our future work, so this work is continuing. It's not stopped yet. Almost in the beginning, and we continue to do more absorption tests that are still ongoing with our partner, and we aim to perform some additional analysis tests like HPS, Raman, maybe a 0-point charge, and C-toxicity, of course, and toxicity evaluation for in vivo applications in the future. So I want to thank the CISECO, so my laboratory when I'm in working, and the project Feed Value, that I'm research fellow, my university, and my supervisors, Dr. Paula Ferreira and Dr. Claudio Nunes. And thank you all too. Thank you.
Thank you very much, Mr. Correa, for your presentation. Very interesting presentation. If you have any question or online. No, thank you again for your presentation.
Thank you very much for the opportunity.
Our next presentation is from Institute of Interdisciplinary Research, Alexandru Ioan Cuza, University of Iași. Mrs. Maftea Andreea Elena is online, I understand. Hello.
Yes.
Good morning.
Yes. Hello, everyone. Yes, one moment to share my presentation. Okay. Can you see?
Yeah.
Oh, yeah. Okay. Okay, good morning, everyone, and thank you for joining my presentation. My name is Andreea Maftei, and I am a researcher from the Research Department of Exact and Natural Sciences of Alexandru Ioan Cuza University of Iași. And today I intend to present some photochromic materials that can remove micropollutant such as bisphenol A from water. So we know that consumer demand for continuous product promote industrial development, releasing dangerous and persistent pollutants into the natural system that affect the human health. The expectation from wastewater treatment will increase and
your slides are not moving.
no.
Maybe make full screen.
Can you try to share your screen, not your presentation, your entire screen?
Okay, one moment, please. Stop sharing. Okay. Sorry, one moment.
Yes, when you press share, please choose
Yes.
the window with entire screen.
Okay, okay. Like that?
1 moment to see.
No.
Okay, okay. And now put
Okay.
the PowerPoint.
Slideshow. Okay. Now it's okay?
Now we see the Teams right now. Teams platform.
The first. Okay. No? It's not working. Okay, sorry.
So first, open your PowerPoint presentation in your
Yes.
laptop. Put it on minimize.
One moment to export this presentation as PowerPoint. Publish. Okay. Now. Like that, it's okay? Oh, no.
Stop share for the moment and try again.
You can see now something? Because I exported my presentation as PDF.
No, we still see the Teams platform. Can you stop sharing and try again?
Okay.
Okay. So you open your presentation in your laptop, put it on minimize, and then share the entire screen.
Yes. Okay.
Okay. Now minimize this page and put the presentation.
Now it's okay? No?
No.
Okay. Now?
You see your presentation on your laptop?
Yes.
No, we don't. We see the Teams page. I think you didn't choose the right window. You have to
Yes, I
choose the
have a presentation with some slides that move, and maybe for this reason, I'm not sure what's
Can you put the
happened.
presentation in the chat and I can put it from here?
Okay. Okay, sorry.
And stop share.
Mm. Okay, I can I send the presentation by mail because by chat I have some results new and I don't want to share with all the people.
Okay, can you send it to mirela.petricianu?
Okay.
And then can we go further and come back to you?
Yes,
Until
thank you.
she gives me the
Yes.
presentation. Okay, thank you.
Thank you.
Can you hear me right now?
Yes.
Oh, thank you. So, Miss Moncho, you have the mic. I was just testing my microphone. Thank you very much.
Okay. In this case, please present the next speaker.
Thank you very much. So the next speaker is Malak Regioui from Laboratory of Organic Chemistry, Catalysis and Environment, Chemistry Department, Faculty of Science, Tofail University, Kenitra, Morocco. So with the paper named Corrosion Inhibition of B66 bronze in 3% natrium chloride, I think, using A1234 triazole derivative combined experimental and theoretical investigations. The floor is yours.
I don't know if he is online. I can't see him.
And the next one?
The next one it is.
Okay, maybe the next speaker because Mr. Hoyu is not online.
Yes, so Ms. Monteiro, can you introduce him, please?
Okay, our next speaker is, I suppose, Mr. or Mrs., I don't know, Farah from University in Morocco with high performance corrosion inhibition of carbon steel in 1 molar hydrochloric acid using an eco-friendly coapatite phosphate compound. Mr. Or Mrs. Farah online, yes?
Ms. Farah, your microphone is open, but we cannot hear you.
Hear me now?
Yes.
But very slow.
Can
Very
you
low.
share?
Yes. Can you share your presentation, please?
Presentation. You see my presentation?
Yes, we can see it, but we hear you very low. Can you speak louder, please?
Right. So, morning, everyone. My name is Anuhaila from Morocco. I would like to express my gratitude as a committee. This opportunity.
1 second, please.
Is it a problem?
We don't hear you very good, and we cannot see the presentation.
Again.
Can you stop share and try to share again?
I will try to share it again.
Yes.
Yes.
Am I present now?
No, not yet.
Yet?
Da? Ceea, în fine, atâta de chirurg.
Ok.
Așa, și astea sunt staturile depuse. Nu contează cu ei, ABC, trebuie să le văd eu la site. Stai că planul meu era să intru astăzi la FTIP, ca să fii și tu aici.
My presentation now.
Okay, now we can see it, but again, we can hear you very low. Please move closer to your microphone and speak louder, please.
Do you hear me now?
Yes.
Yes.
It's better.
Okay. So, my name is Rano Haila from Morocco. First of all, I would like to express my gratitude to the organizing committee for this opportunity to present my research subject entitled High Performance Corrosion Inhibition of Carbon Steel in 1M HCl using an eco-friendly coapatate phosphate compound. The outline of my presentation is as follows. It begins with an introduction where I will present the problem and the approach proposed to address it. Then I will describe the general context of the study and the materials and methods employed. The next part will focus on the results and their discussion, and I will end with the conclusion. As you know, steel plays a vital role in many industrial applications, such as construction, oil production, and chemical processing. However, when exposed to
Sorry to disturb you
aggressive,
again, but your slides are not moving.
okay, maybe the connection is slow.
Maybe, or you didn't share the entire screen.
Yeah, I will stop it and I will share it again. Okay,
Yes. And
I'll
share
try
the
to
entire
share it.
screen, not just the presentation, okay?
Okay. And now, do you see my presentation?
Wait a second because it's a delay.
Not yet.
Not yet.
Maybe the connection is slow, so I will change. Oh. How about now?
Not yet.
No.
Can you also send it on email and we put it from here?
I will try to send. And now, do you see my presentation?
No,
Ah, yes.
we can see it now. Try
Okay.
to
Can
go
you?
to second slide to see.
Okay. Now,
Now we see first slide.
that the first slide. Let's see.
Yes.
Or maybe no. Okay.
Maybe if you send your presentation to put from
No,
here.
I can send this because I have a new result in my presentation. It does not publish yet. So
But it's not changing. We only see the first slide.
okay, I will change the connection and I will be back to present. Okay.
Okay. So we'll go back to Mrs. Andrea and come back to you, okay?
Okay, thank you very much.
Thank you. We received a presentation from Mrs. Maftei. So,
One second.
Okay, perfect. The second slide, please.
okay,
Okay.
we see the second slide.
Yes, perfect. Yes. Okay. We know that consumer demand for continuous product promote industrial development, releasing dangerous and persistent pollutant into the natural system that affect the human health and also the entire ecosystem. So the expectation for wastewater treatment will increase, and eco-friendly materials should be feasible option for pollutant removal. Over the last decade, many resources have been invested in the finding the best environmental friendly solution for water cleanup. Many different methods. The next slide, please. Okay, many different methods such as membrane filtration, biological treatment, adsorption has been used to treat water. But this traditional method have the advantage of being easy and cheap to operate. But they have some limitation, such as the requirement of additional treatment for some persistent organic compounds. So the advanced oxidation processes, such as photocatalysis, have gained a major interest in the field of water remediation because of high capacity to generate under ultraviolet or visible light reactive oxygen species, such as hydroxyl or hydroperoxyl radicals, known strong and non-selective oxidant that effectively degrade a wide range of organic compounds with high reaction rate. So let's start with spiropyrons. They are fascinating molecules that belong Okay, perfect. Spiropyrons are fascinating molecules that belong to a class of photochromic compounds, material that change structures when exposed to light. They can switch between two isomeric form, as well as in the dark, the spiral form, a closed ring structures, and when exposed to ultraviolet or visible lights, it transforms into a merocyanine structures, which has a different color, polarity, and electronic structures, and of course is highly reactive. Spiropyrons' photoswitchable properties give them many advantages for detecting target molecules, making them suitable for a wide range of application, including also water treatment. So my research is focused, our research, in fact, it's focused on the removal of some pollutant from water, utilizing this type of materials, spiropyrons, and ultraviolet irradiation. But sometimes the photocatalyzed can be difficult to recover from water after use. That is why spiropyron were immobilized on a magnetic support to facilitate the recovery from the reaction. And magnetic nanomaterials such as magnetite enable the magnetic separation by simple use a magnet to pull the catalyzed out after the treatment is completed. So we have an hybrid materials that contain spiropyrons and magnetic core, which is responsive and efficient to ultraviolet light, capable of generating reactive oxygen species, and also is reusable due to its easy recovery. Next, please. As a process, we use photocatalysis because under ultraviolet, spiropyrans convert to myrocyanin structure, generating reactive oxygen species, which then attack and decompose organic pollutant. Magnetic nanoparticles act only as a magnetic support, and once the process is complete, the particle can be easily removed from the water by applying a magnetic field, making the process much more efficient and, of course, cost effective. As a model compounds from water, we choose a pollutant like bisphenol A. Science is commonly found in food containers, water bottles, and even the inside of metal can. But many people don't realize that bisphenol A can leach into the water we drink, especially when the plastics is exposed to heat or sunlight. And once it's enter in our water system from improper disposal, it's very difficult to remove. Okay, next, please. So let's break down the process. Load spiropyrans on a magnetic nanoparticle, expose the composite to ultraviolet light, and spiropyran photoinduced transformation and also activating the photocatalytic activity. And the pollutant in water will break down by the reactive species generated in the system. And once the treatment is done, an external magnet can easily recover the magnet nanoparticles. So the major benefit here is that we can remove contaminate efficiently without generating secondary waste or requirement some expensive filtration system. It's both sustainable and reusable. Okay, next, please. The obtained catalyst was characterized by different analytical methods such as X-ray diffraction, Fourier transform spectroscopy, or electron spin resonance spectroscopy. The result obtained by XRD indicate the presence of magnetite as the predominant crystalline phases, and the FTIR spectra show characteristics bands that corresponding to magnetite or a spiropyran, confirming also the successful functionalization of the materials. Electron spin resonance spectroscopy demonstrate that the catalyst efficiently generate active oxygen species. The catalytic activity of spirospirans, next please. Okay. The catalytic activity of spiropyrans has been also evaluated in the degradation of bisphenol A, and the preliminary results obtained show that in the first 50 minutes of ultraviolet irradiation in the presence of a small quantity of hydrogen peroxide concentration, more than 89% of bisphenol A was removed. So we can observe that the increase in material dosage accelerate the removal of the pollutant, and the optimum concentration selected for future experiments was 1 gram per liter. To evaluate material stability, we continued with reuse experiments. And as we can observe, the performance of spiropyrans remains high even after 4 cycles of reuse. Okay, thank you. Next. This material, spiropyron-based magnetic nanoparticle, can be also applied to remove another pollutants like methylene blue, reactive black 5, or rhodamine B, or pharmaceutical compounds such as carbamazepine or tetracycline, and of course for other persistent organic compounds. So overall, spiropyrons-based magnetic photocatalysts are promising materials that can be successful used in depollution technologies. As we look to greener and smarter solutions for pollution, materials like that could play a central role in building a cleaner and a more sustainable world. Thank you for your attention. Next. Thank you.
Thank you for your presentation, Mrs. Maftei. If are any questions or online? No. Thank you again.
Thank you.
And we come back to Mrs. Ferra. And I want to ask Mrs. Faleio from Portugal to prepare after Mrs. Ferra her presentation. Thank you. Mrs. Ferra?
Chair.
Again, closer to your microphone, please.
Do you see my presentation?
No.
No.
And now?
1 second, please.
Let's wait. Okay. Can you try change one slide?
No?
No, it's only first slide.
Just the first slide.
Yes.
Yes. Actually, the problem. I can't move my slide. To present.
Did you share your entire screen?
Yeah, I share it, but it didn't. Let's try it again. Share it. Okay. Do you see it or no?
Again, the first slide.
That's the first slide.
Yes. Now it's moving.
Okay.
Good morning, everyone. My name is Farah from Morocco. First of all, I would like to express my gratitude to the organizing committee for the opportunity to present my research entitled High Performance Pollution Inhibition of Plant Cell in 1N HCl using a eco-friendly magnetic phosphate. So the outline of my presentation is as follows. It begins with an introduction, where I will present the problem and the future focus. Then I will describe the general context of the study and the materials and methods employed. The next part will focus on the results and their discussion, and I will end with a conclusion. So as you can see, cells play a vital role in many industrial applications, such as construction oil, production, and chemical processing. However, when exposure to aggressive environments like acidic solution, it undergoes severe corrosion, leading to significant material loss. To prevent this, corrosion inhibitors are widely used, and recently, green inhibitors have attracted much attention due to their environmental advantages. In this context, we focus on calcium phosphate, a non-toxic and biocompatible material commonly used in the medical field. To improve its protective performance, we incorporated cobalt ion into the calcium phosphate structure, forming a copolypeptide phosphate, which we studied as a potential eco-friendly inhibitor for carbon cell in 1N hydrochloric acid. So the objective of this study is divided into three main parts. The first, we focus on the synthesis of a new phosphate-based material by incorporation cobalt ion into a calcium phosphate structure. The second, we carried out the characterization of the synthesized material using several analytical techniques to confirm its structure and composition. And finally, we evaluated the corrosion inhibition performance of this compounded phosphate compound in 1N hydrochloric acid. So the synthesis of the phosphate material with cobalt ion was carried out using a co-precipitation methods in a liquid medium. This process involves the mixing of two solutions. The first contains calcium nitrate and cobalt nitrate, while the second contains ammonium hydrogen-phosphate. The resulting co-precipitate was then filtered, washed several times with a washing solution, and dried for 24 hours at 80 degrees. The obtained product was subsequently characterized using X-ray diffraction, infrared spectroscopy, and scanning electron microscopy coupled with energy dispersive X-ray analysis. Concerning the electrochemical test, they were performed in a 3-electrode cell configuration. The system consisted of a working electrode, which was a carbon steel plate, a platinum counter electrode, and a reference electrode of EgCl type. In addition, the surface film formed on the carbon steel after immersion was examined using a thin EDX to analyze its morphology and elemental composition. So the infrared spectroscopy analysis shows all the characteristic bands of calcium phosphate. We can observe a broad vibration band between 3000 centimeter -1 and 3500 centimeter -1, which corresponds to the stretching vibration of hydroxide groups. In addition, the band related to orthophosphate groups are clearly identified with symmetric stretching vibration near 1000 centimeter -1 and stretching vibration around 700 centimeter -1, characteristic of hydrogen phosphate group. The infrared diffraction pattern indicates that the obtained phosphate material is poorly crystallized, suggesting a low degree of structural order. Finally, the same EDX characterization confirms the presence of cobalt ion in the EDX spectra, demonstrating the successful incorporation of cobalt into the calcium phosphate structure during the synthesis process. The evaluation of the corrosion inhibition performance of the coapacitic material was carried out using potential dynamic polarization measurements. The results show that adding our inhibitor at different concentration in the diffusive medium slightly shifts the pollution potential compared to the blank. We also observe that the difference between the pollution potential of the blank and that of the inhibited system does not exceed plus or minus 85 millivolt, suggesting that the inhibitor acts as a mixed type inhibitor in this medium. In addition, the collision current density decreases with the addition of the inhibitor, reaching an optimal value, which in turn leads to a reduction in the collision rate of carbon cell in presence of carbon inhibitor. The electrochemical parameters obtained from the extrapolation of Staffel curves show that the collision current density decreases with the addition of different concentration of the phosphate material. The optimal inhibition was observed at a concentration of 50 ppm, reaching maximum efficiency of 96.5%. This behavior can be explained by the formation of a protective layer at the steel surface, created by the absorption of inhibitor molecule, which effectively reduce the pollution rate. So, to better understand the process occurring at the cell inhibitor interface, electrochemical impedance spectroscopy measurements were performed. The Nyquist diagram shows that the diameter of the capacitive loop increases with the addition of the inhibitor, reaching a maximum at 50 ppm. Unfortunately, the mechanism of inhibition does not change with the addition of the inhibitor. Another observation is that the diagrams consist of a single capacitive loop, indicating an enhancement in corrosion protection of the carbon steel surface. The plots confirm the presence of a single time constant in the chloride acidic medium, both with and without the inhibitor, supporting the validity of the equivalent circuit model used to reproduce the EIS spectrum. So the parameters extracted from the ENS diagram using a simple equivalence circuit confirm this observation. As you can see, the charge transfer resistance reaches its maximum at the optimal concentration of phosphate inhibitor. This increase in charge transfer resistance corresponds to an inhibition efficiency of 96.4%, which clearly highlights the effectiveness of the inhibitor. Overall, the electrochemical results demonstrate that the incorporation of cobalt ion significantly improves the corrosion inhibition performance compared to calcium phosphate apatite inhibitor in the same medium. Voltammogram show a reduction of both anodic and cathodic forces, confirming that the coapatite phosphate acts as a mixed type inhibitor. These results demonstrate the strong inhibitory performance of the compound and highlight its role in improving the electrochemical stability of steel in acidic medium. So the study of the temperature effect by potentiodynamic analyze carried out in the presence of the phosphate material show that the corrosion current density increases with rising temperature compared to the blank medium. However, the inhibition efficiency slightly decreases from 96.5% to 88.3% with increases of temperature. This temperature study also allowed us to calculate the thermodynamic parameters. We observed that the activation energy increases in the presence of our inhibitor, indicating that the absorption of the inhibitor on the carbon steel surface is of physical nature. Moreover, The standard enthalpy values are positive, confirming that the adsorption process is endothermic. And finally, the entropy values are negative, and the presence of the inhibitor leads to an increase in entropy, reflecting a more ordered adsorption process at the stale solution interface. So in order to confirm the formation of a protective layer by our inhibitor, the morphology of these cell surfaces was examined using same analysis in 1M hydrochloride acid. As you can see, the same image of the blank shows spike and inhomogeneity indicating significant surface damage. In contrast, when the phosphate inhibitor is present, the carbon steel surface appears much smoother and less damaged due to the formation of a protective layer. The presence of this layer was further confirmed by EDX analysis, showing phosphate and calcium, which are main compounds, along with a cobalt peak demonstration that the synthesized material effectively protects the steel by forming a protective film at the carbon steel surfaces. As a conclusion, the cooperative phosphate compound shows excellent corrosion inhibition performance in 1M-HCl medium. The analysis of the electrochemical polarization curves and impedance diagram of the carbon steel indicates that the optimum concentration of 50 m provide a maximum inhibition efficiency of about 96%. The incorporation of cobalt ion into calcium phosphate enhance its protective ability, leading to formation of a stable and adherence protective layer of the cell surface. Thermodynamic parameters confirm that the absorption is physical, spontaneous, and endothermic. The analysis of the cell surface morphology by same imaging coupled with EDX confirms the existence of a protective layer at the steel HCl1M interface after the addition of cooperative material. And finally, this eco-friendly compound can be considered a promotion and sustainable corrosion inhibitor for carbon steel in acidic water. Finally, I would like to thank you for your kind attention. And thank you.
Thank you very much for your presentation.
Thank you.
If there are any questions?
Yes, I have a question.
Okay.
So, yeah, well, great presentation. I'm interested in the impedance spectroscopy measurements. And my question is, what is the error of dosing 50 ppm of inhibitor? Because it's a very low concentration if you think about it.
Yes, I measured it's a low concentration, yes, but its effectiveness for the inhibitor.
Well, I didn't understand it, but how did you dose it?
How I am dose it? I put it on the a mass.
Okay.
I can't dose it.
Okay, thank you. Yeah, that's okay. Thank you very much.
Thank you for you.
Mr. Simeon, do you want to present the next speaker?
Yes, thank you very much.
Thank you.
So the next speaker is Mariana Valejo from CISECO Aveiro Institute of Materials, University of Aveiro, Portugal, if she's online, with the presentation called Eco-Friendly Paper Coatings via Vaporization of Potato, Onion, and Garlic Processing Waste. The floor is yours.
Thank you. Going to Can you see my presentation?
Yes.
Yes, you can see it.
Yes. Can you hear me well?
Yes.
Yes.
Okay. So good morning, everyone. I'm Mariana, PhD student from University of Aveiro, and I'm here to present a little bit of the work that I've been developing in my PhD. So paper industry, this is one of the most important worldwide. It produces more than 400 million tons of paper every year. And because paper is highly hydrophilic, we have a major issue. It has weak barrier properties, more specifically high water vapor transmission rates. And because of this, the industry usually turns to coating strategies that are usually based in fossil oil polymers that, although they have good low water vapor transmission rates, they are usually non-biodegradable, which brings us environmental problems because they usually have to end up in landfills or be incinerated. And additionally, because they do not have natural adhesion to the paper surface, they need external treatment such as a corona treatment. And because of these reasons, United Nations and their sustainable goals from the 2030 agenda, industry is trying to find alternative solutions, and one of them is the use of bioplastics. And under this context, in this work, it is proposed the use of agri-food byproducts to produce bioplastics, more specifically, the starch that's recovered from the potato washing slurries that it's a natural biopolymer that has the amazing ability to turn into a thermoplastic material, which is very good for extrusion process and has a natural compatibility to the paper surface. However, we still have a problem to solve regarding its water vapor transmission rates. And we also propose in this work to use other agri-food byproducts to improve these barrier properties, more specifically the peels from the onion and garlic industries that are very rich in natural molecules that can be used to improve these barrier properties. They are naturally dry, they are very lightweight, which is very used to transport, and they are heat resistant, which is a very important feature in this industry. So for the methodology, first we recovered the starch from the potato washing slurries, and under the right conditions, it was transformed into thermoplastic starch, more specifically TPS. And through hot pressing, we created TPS bioplastics. Using the same process and using onion peels powder as an additive in different concentrations for compressing purposes, we obtained our TPS onion peel bioplastics, and we also did the same with garlic peel as an additive. So here we have the final images of the obtained bioplastics, and as we could observe comparatively to the control, onion peel conferred like an orange-like tones to the TPS-based bioplastics, while garlic peel conferred a brownish tone to the bioplastics. However, in both cases, we saw an intensity in coloration with increasing additive of onion peel and garlic peel, and also a decrease in transparency. When observing cross-section images, as it is possible to see, while the control has a very smooth surface, when we observe the cross sections of the bioplastics containing the additives, we can see that in both cases the particles were very well included into the matrices. However, we have heterogeneity in both cases, and also it is very notorious the increase in concentration of particles introduced into the matrix when we increase the percentages of additive. Here we have FTIR of these bioplastics, and we observed in all the bioplastics the presence of the typical peaks of the TPS, which indicates that this additive did not interfere with the development of the matrix. However, we observed new peaks that are related to the components of the additives that are more intense in higher concentrations of additive. So regarding the mechanical performance of these bioplastics, we observed that the thickness was not significantly changed between the bioplastics. However, when we observe the rigidity of these materials, we see that percentages above 10% of onion peel increase significantly the rigidity of the matrices. But when we use garlic peel, we tend to have a more elastic material. When we observe the stretchability of these materials, we can see that the tendency for both additives is to decrease when we increase the quantity. However, comparing both additives, garlic peel tends to show higher stretchability values when comparatively to the bioplastics containing onion peel. And finally, when we observe the tensile strength of these materials, we can see that with onion peel, we obtain higher values. And when we use 15%, more than 15% of onion peel, this tensile strength tends to decrease, while the garlic peel has an opposite tendency, except when you use 15%. We analyzed the WVTR of these bioplastics, and we observed that when using onion peel values above 15% and garlic peel at 20%, it decreased significantly our water vapor transmission rates comparatively to our control. When analyzing the water contact angle of these materials to observe the wettability of their surfaces, we observe that when we use onion peel an additive above 5%, we could turn this this bioplastic surface from hydrophilic to hydrophobic, which is very important in this case. We also analyzed the antioxidant activity of these bioplastics, and we observed that both additives conferred an antioxidant activity. However, looking closer, after only 20 minutes and using the maximum percentage of onion peel, we could obtain already the maximum inhibition of our radical. So these bioplastics were then applied into paper surface through hot pressing. And for all of them, control TPS onion peel and TPS garlic peel, there was an effective thermal sealing into the paper surface. And here we have the final images of the paper coated, all the papers coated with the respective bioplastics. And as expected, we see an increase of the natural pigmentation of these coated papers when we increase the additive. And we also observed a glossy surface above the paper. So we analyzed again the WVTR of the materials, and we observed that with increasing additive, this value decreased significantly as expected, and it was not when comparatively to the industrial value, that is the last value, where we have a paper coated with polyethylene, we could have three samples that above 15% for each additive could be comparable to the values of the industrial sample. So to conclude, we observe that both additives are very compatible with all the processability involved in the development of these coated papers, which is very positive. And while onion peel increased the rigidity of these bioplastics, garlic peel, on the other hand, increased the elasticity of these bioplastics. And both additives increase the water resistance of these coatings and also confer the antioxidant properties of the bioplastic, noting that onion peel had a much stronger antioxidant activity than garlic peel. And finally, these coatings showed a very good natural adhesion to the paper surface without compromising our water vapor transmission rates. And finally, I would like to thank all the funding entities and the companies and groups that are involved in this work. And thank you very much for your attention.
Thank you very much, Mariana, for the nice presentation. Very interesting. First of all, I have a question, if I'm allowed to. What is the rate of this process for obtaining this kind of materials? I mean, what is the waste? What is good and what is bad?
The rate?
Yes, the rate of obtaining. Yes.
You mean the time that it's necessary to obtain these materials?
No, not the time. I mean, you are having some kind of waste process when you are fabricating. What is good and what is bad? I'm interested about this ratio. I mean, what you are gaining.
So
for
here,
1 kilo of potatoes,
the goal,
let's say.
yeah. So here, this agri-food byproduct, it is directly collected from the company. So we are talking about the outer onion peels and the outer garlic peels that the industry does not want. So what I do is I collect directly and I use 100% of it. I do not do some kind of extraction. I only powder it and use directly. So this is a way that we can, because usually what happens in the studies involving the use of agri-food byproducts as additives, usually what is made is previous extractions, so parts of these byproducts. So our goal here is to valorize 100% of these byproducts. So have a 100% to include the concept of circular economy as a whole.
Yeah,
so
very,
just
very
to
interesting.
To clean it, powder it, and use it directly.
Yeah, very, very, very interesting. Yes, thank you very much for answering to my question. If there are any questions from the audience or online. If not, let's thank the speaker again. And Ms. Mocho, you have the mic.
You can present the next speaker if you want.
Yes, it's my pleasure. In fact, I would like to introduce Mr. Radu Robert Piticescu from the National Research and Development Institute for Non-Ferrous and Rare Metals from Romania, with the work entitled Hydrothermal Synthesis of Reo RNTS doped TO2 nanostructured powders for 3D printing application in photocatalysis. Mr. Piticescu, the floor is yours.
Thank you very much. Thank you very much for the presentation. I'm glad to hear you again, to meet again.
Yes, it's the same from my side.
I will try to share my presentation. Let's see how I.
We can see.
Okay. Do you see it?
Yes.
Yes, now it's fine.
Okay, thank you very much again. I will talk. I make first an introduction on the importance of the topic, our methodology, experimental results and discussions, and conclusions and future works. Mentioning that it is a recent project that we started, and there will be still many many research in France. As my colleague Mrs. Maftei presented, the water regulations are very, very strict in the European and according to the European Green Deal. It is absolutely necessary to treat the different types of wastewaters, of urban wastewaters and industrial wastewater. The problem is that costs of treatment are increasing, and it is so necessary to find technological solutions to reduce the cost and to find also environmental friendly solutions. One way it is used to use heterogeneous photocatalysis based on using semiconductors like titanium oxide, zinc oxide, iron oxide, and sulfides. Titanium oxide is the most used due to its high photocatalytic activity and low toxicity and chemical stability, and but has some deficiencies mainly related to the fact that it is active only in UV and not in visible spectra, and this is also explained by the band gap and the combination of electron-hole pairs. So one solution that was proposed by physicians and by researchers was to dope with traditional metals and develop also nanostructure composites based on doped titanium oxide and carbon nanotubes or graphene oxides. To obtain such kind of materials, mainly salt gel procedures have been used, and also some mentioned about the hydrothermal synthesis of titanium oxide and attached doped with neodymium ions. Our approach is we try to obtain active photocatalytic systems based by integrating two emergent technologies, namely hydrothermal synthesis of doped titanium oxide and additive manufacturing using paste from powders obtained by hydrothermal synthesis. The idea of using additive manufacturing is similar with what Mrs. Maftei presented to reduce the loss of powders during photocatalysis process. We developed for the synthesis, for hydrothermal synthesis, we developed, we proposed a second order factorial experiment where we changed the content of carbon nanotubes and lanthanum oxides, and we as objective functions we measure the bed specific surface area and also the photocatalytic efficiency. And we characterize these materials by chemical analysis, FTIR, and X-ray diffraction. The methodology for hydrothermal synthesis start with dispersing commercial carbon nanotubes in distilled water, ultrasonic treatment, then doping titanium oxychloride, mixing titanium oxychloride solution with lanthanum oxide and dissolving it, and then precipitation with potassium hydroxide, and finally we make hydrothermal synthesis in an autoclave at 200 Celsius degrees and 2 hours. Where I will present only the extreme composition. So the sample one is with lower with the lowest carbon nanotubes and lanthanum oxide, only 1% of each, and the other one is sample 4 with 3 lanthanum C carbon nanotube content and 5% of lanthanum oxide. So in both cases, we obtain a crystalline powders with only anatase structure. So no other type like rutil it is observed. So this is very good because it is well known that anatase is the most active photocatalyst. The specific surface area vary. It is also high, varying from 150 to about 285 meters per square meters per grams. So this is very important also to enhance the photocatalysis. And the photocatalytic activity was done on 2 compounds. One, it is methyl orange, which is a kind of let's say it is used frequently as material to show that to see the activity, the photocatalytic activity. It is a kind of standard material. In the case of methyl orange, the decontamination efficiency is between 89 to 95% for both, practically for both samples. Anyway, the best results were obtained for the powder with 1%. Doped with 1% lanthanum oxide and containing 1% of carbon nanotube. We made also measurement of the photocatalytic activity for amoxicillin, and it is also very high efficiency, going up to 95% decomposition. And based on these measurements, we decided to select the composition with 1% lanthanum oxide and containing 1% carbon nanotube for next step of obtaining materials, photocatalytic materials structures by 3D printing. 3D printing or additive manufacturing was performed using adding this powder in sodium salt of polyacrylic acid and using aqueous polyurethane dispersion, obtained a paste that could be prepared and can be used for printing. The mixing program, it is presented here, and the printing parameters, we use on a nozzle of 400 micrometers. The pressure varied from 1.8 to 2.8 bars, and the speed of deposition from 515 to 22 millimeters per second. And you can see the process here, starting how we can use this program, the CAD file program, to obtain different types of structures, 3D printed structures, varying. We varied the distance between the layers. We varied also the pattern angles to see how this influences the mechanical properties as the stability of the structure. And some examples are presented here. You can see these 3D printing structures obtained from titanium oxide doped with lanthanum oxide and carbon nanotubes are stable and can be further used as a photocatalyst. So our future work is to our conclusion. So we could obtain only we could produce by hydrothermal synthesis TO2 anatase at low temperatures and pressures with controlled composition, with high specific area. The efficiency for the gradation of methyl orange was between 89 to 95% and 89 to 98% for the gradation of amoxicillin. And composites with low content, 1% lanthanum to oxygen 3 and 1% carbon nanotube seems to be the optimal solutions for photocatalysis. And in the next period, we will model and optimize the process, the hydrothermal synthesis process, also replacing carbon nanotubes with graphene oxides to enhance the photocatalytic activity. We'll optimize additive manufacturing process, and we will intend to obtain 3D printed samples for testing on pilot size UV decontamination installation as the industrial partner. The idea is that this process can help us to obtain such kind of 3D printed nanostructures at different sizes, at different diameters, and different heights that are requested by the company. Okay, and finally. Sorry. No, something wrong here. Just a moment. And finally, I want to thanks to my young colleagues, and especially to Stefania Karamarin and Miruna Yotsav for Stefania Karamarin for the synthesis and 3D printing, Miruna for bed surface analysis, Valentin Drăguț for the XRD measurements, Madalina Laura Cursalo for FTIR, and Gabriela Ioniță for the literature survey and optimizing based on this paste composition. And thank you very much for your attention.
Thank you, Mr. Piticescu, for the nice presentation. Very, very interesting approach of this combination of titanium oxide with lanthanum oxide and carbon nanotubes, because as far as I know, correct me if I'm wrong, the lanthanum oxide alone has a limited photocatalytic activity, but as I can see in your presentation, this has bring an enhancement of photocatalytic activity in this kind of combination with titanium oxide and what you have put it there. So very, very interesting. I can find it. Thank you very much.
Thank you very much for your appreciation.
The speaker is open for questions from the audience or from online.
Yeah, you can come here, please. Yeah.
We have one question here.
Is the information the photodegradation was done under UV or visible light? Which one?
So,
In
Mr. Piticescu, someone asked if the photodegradation was under UV or visible light.
So there is some mixing of the. Okay, can you please repeat?
The photodegradation was under UV or visible light?
Was done both under UV and visible light.
In the same time?
I suppose it's UV light. I suppose it's UV light for photodegradation, but it's possible to have the special light which
yes,
combine,
a special light.
which
Yes,
combine UV and visible light.
I sorry that I have to I didn't mention here, but what the industrial partner has used I forgot to put here.
Thank you. Other question? No? From online? Thank you again for your presentation, Mr. Piticescu.
Thank you very much.
And we have two more presentations because he's online now. Mr. Rakesh Kaur from Department of Chemistry, Government SSP College, Varaseon, India. Mr. Kaur, you can hear us?
Yes, ma'am, I am here.
Okay.
Can you hear me?
Yes, we can see
Okay,
you.
ma'am.
I hear you.
I am presenting my screen.
Please share your presentation.
Yes, ma'am.
Okay.
Can you see the presentation, ma'am?
Yes. Yes.
Okay, thank you very much, ma'am. First of all, I would like to say thanks to entire organizing team, which is conducting 8th International Conference on Emerging Technologies in Material Engineering. I am Dr. Rakesh Chore from chemistry. Basically, I am from India, Department of Chemistry, Government SSP College, Varasoni. And right now I am working as an assistant professor in Government College. So here I am going to start my presentation. My research work on electrochemical and pharmacological analysis of copper coumarin complex. So I already given my introduction. This presentation contains introduction, experimental section, pharmacological study, resultant discussion, and conclusion. And some references also are there. So the introduction. A group of pharmaceutical called anticoagulant. So here I discuss about the coumarin drug, that is anticoagulant drug. And through the in vivo study, we can get the medication for thrombotic disorders. Coumarin is a naturally occurring secondary plant product. It is basically obtained from the tonka bean, and it is also found in many grasses and many plants, in woodruff, in dates, and especially in certain types of cinnamons. This is the structure of coumarin, and coumarin is a group of organic compound found widely in plants and derivatives from the amino acid phenylalanine. So, in the experimental section, first of all, I have done the study of the pharmacological study. For that, I have choose, because it is an electro analytical technique. So we have to choose the supporting electrolyte to conduct the experiment. So here we have chosen the ammonium tartrate used as a supporting electrolyte, and the solution reagent prepared dissolve in requisite amount of the respective chemicals in double distilled water. The drug under study was procured from the market, that is coumarin. So for the analyte, I have made the solution which is 0.01 mole. Stock solution of coumarin was prepared by dissolving the weighted amount of the drug in methanol and water. The direct current polarography and the differential pulse polarography study were carried out on an Alico microprocessor-based polarographic analyzer, which is the model number CL362. In the pharmacological study, we have calculated the prothrombin time, which is obtained from the albino rats. Pharmacological screening of coumarin and its derivative molecule was done in vivo through the study of anticoagulation activity to check efficiency and safety of prepared new molecule of the coumarin. since coumarin is an indirect acting anticoagulant which inhibits the clotting of blood in vivo. Thus, the mode of screening of new modified molecule of coumarin was screened through same pharmacological test, that is average plasma prothrombin time determination, that is known as the Quick's method. The in vivo experiments were done using albino mice animals. Coumarin anticoagulant act by inhibiting the synthesis of vitamin K dependent clotting factors, which include factors 2, 7, 9, and 10. Vitamin K is an essential cofactor for the post ribosomal synthesis of vitamin K dependent clotting factors. Pharmacological study, that is the prothrombin time continues. The anticoagulation effect generally occurs within 24 hours after drug administration. However, peak anticoagulation effect may be delayed for 72 to 96 hours. Anticoagulants have no direct effect on an established thrombus, nor do they reverse isthmic tissue damage. However, once a thrombus has occurred, the goal of anticoagulant treatment is to prevent further extension of the formed clot and prevent secondary thromboplastin complications, which may result in serious and possibly fatal sequela. So, what is the Quick's method? Quick's method is the method in which we can calculate the prothrombin time. One stage plasma prothrombin time was calculated by Quick's method. For this, 2 ml of fresh citrated plasma obtained as mentioned in the experimental part. 0.1 ml of this citrated plasma was mixed with 0.1 ml of thromboplastin in a glass tube or in a dish placed in a water bath at 37 degrees Celsius. After a delay of 2 minutes, 0.1 ml of pre-warmed 0.025 mole CaCl2 solution was added to this mixture carefully and mixed well. A stopwatch was started and the tube was held with its lower end submerged in water bath at 37 degrees Celsius. The tube was continuously but gently inclined from the vertical to just short of the horizontal so that its contents could be observed for the first sign of clotting and time was noted. The test was repeated 3 times with the same citrated plasma samples and average prothrombin time was calculated. In vivo study that is used as a albino mice plasma, coumarin dose shows a relationship between anticoagulation effect and antithrombotic efficiency. The anticoagulation activity of coumarin and modified molecule was screened in albino mice animals for in vivo effect. For this, a standard procedure was adopted for dose of drugs under study and for in vitro studies, the dose was designed as 1 ml per 100 kg. So, in the pharmacological study, each drug was administered orally on a set of 4 healthy animals according to their weight, that is albino mice. 2 ml of venous blood samples of the mice were collected through orbital puncture after 24 hours of dose. Without delaying, blood samples were mixed with sodium citrate in a requisite amount and citrated plasma was obtained from each blood sample. This citrated plasma obtained from albino mice for each newly designed coumarin molecule was used to determine average prothrombin time in seconds by Quick's method. So what are the result and discussion? First of all, the polarographic analysis. Coumarin and its complexes give well-defined cathodic reduction wave at pH 8.2 plus minus 0.02 in the 0.2 mole of ammonium tartrate that is used as a supporting electrolyte. On increasing the ligand concentration in each, remember the reagent is here in copper. So ligand concentration in each set and subjecting these experimental sets to polarography. It was observed that the half wave potential shifted to a more electronegative value. It shows that if the potential shifted toward the more electronegative value, it means the potential of the drug has been increased. The plot of the change in half-wave potential with logarithm of change in ligand concentration yielded a straight line, suggesting the formation of single complex species in case of copper coumarin system. So the table formation of constant of coumarin complex is shown here. That is the stoichiometry. So the ligand treatment of the observed polarographic data in case of copper coumarin system revealed the stoichiometry and formation constant of the complexes formed. So this is the table for the polarographic data of copper coumarin complex system where the concentration of ligands you can see. Now these are the polarograms and these are the plot of half-wave potential and log Cx. That is the copper coumarin complex. Now, in the result and discussion section, we'll talk about the in vivo study that is on the albino rats anticoagulation action. In the in vivo anticoagulation action of coumarin and its modified molecule was screened on albino mice. The result of anticoagulation activity obtained for normal and each test sample species of drugs and are shown in respective table. The average prothrombin time as observed using modified molecular form of coumarin is depicted in the bar diagram, which is shown in later. It is quite clear from the bar diagram that through the mean average prothrombin time using coumarin as anticoagulant increases to 20.74 seconds as compared to that observed with pure blood plasma of the animal, which is 11.94 seconds without drug dose. But coumarin modified molecule shows increased anticoagulation activity, that is prothrombin time of 23.84 seconds. So the prothrombin time for the modified form of the drug will increased. So this table shows the result how the prothrombin time increases, and you can see the results are A, B, C are there, and the mean prothrombin time was 11.85 for the normal anticoagulation effect. When we take the coumarin drug, and then the result shows that the mean average prothrombin time was 20.74. So big difference between them, 11.85 to 20.74. It shows that the anticoagulation potential is high for the coumarin because it is an anticoagulation drug. But if we analyze the copper coumarin complex, and then the result shows that the mean average prothrombin time was 22.81, which is increased from parent drug. So this is the bar diagram, which shows the difference between coumarin and copper coumarin complex. Now the conclusion. On the basis of reported data and ongoing discussion, it could be concluded that the proposed electroanalytical method provides accurate and precise data on trace analysis of coumarin and its modified form. The technique are best suited because of simplicity as well as economics of the procedure for the simultaneous quantitative and qualitative determination of trace of active principles of drugs and may be recommended for their possible use in medicinal industry. I also recommend modified drugs to the therapeutic expert to ascertain the possible use of these modified forms as more potent anticoagulants in lieu of parent coumarin drug. So these are the references which have been used. Thank you very much for watching this.
Thank you for your presentation. If there are any questions from online, any question? No, thank you again. And our last, yes?
Ma'am, can we take a picture? Thank you, ma'am.
And our last speaker is Mr. Malek Rehyoi, I hope to pronounce correctly, from Faculty of Science, IBN Tofel University from Morocco.
Hi, thank you.
Please, because we are in late, please be short. Mrs.
Yeah. Do you see my presentation?
Yes, we can see your presentation.
Okay, so my name is Malak Rahiwi. I have a PhD from the Laboratory of Organic Chemistry, Catalysis and Environment in the Department of Chemistry in Ibn Tufayl University from Morocco. Today I will present my subjects, my research studies entitled Corrosion Inhibition of B66 brands in 3 points sodium chloride using a 1,2,4-triazole derivative combined experimental and theoretical investigations. To outline today's presentation, we will start with an introduction followed by materials and methods, then the extraction and characterization, and then application and inhibition of corrosion, and then the conclusion. So as you know, brands is used in the industry due to their multiple properties like high electrical and thermal conductivities and mechanical workability. However, bronze is subject to corrosion in aggressive environments containing carbonates, nitrates, chlorides, or sulfates. So, corrosion causes significant damage and huge economic loss. So the use of 1,2,4-triazole derivative as a corrosion inhibitor for brands B66 in a 3.3% sodium chloride solution. So for the working methodology, so first is the synthesizes of the molecule via phase transfer catalysis and using alkylating agent. So the purification of the final products was used via crystallization and RMN carbon-13 spectra analysis. And for the corrosion inhibition, we used gravimetric methods, electrochemical methods, adsorption isotherms, and surface analysis, VSM and EDS. So now let's go to the application in inhibition of corrosion of brands in sodium chloride medium. So we comparatively report the corrosion rate and the inhibitory efficiencies by assessing weight loss. As shown from the figure, the corrosion rate steadily decreased as the concentration of the inhibitor increased. This reduction in corrosion is likely due to the adsorption of of inhibitor molecules onto the branch surface, enhancing protection against degradation. So the maximum inhibition efficiency is 91.34%. So the absorption spectroscopy showed the same thing with a high inhibition efficiency of 91.01%. Let's move on to the electrochemical measurements. So potentiodynamic polarization curves are valuable tools for estimating the corrosion rate and understanding the mechanism and the formation of the inhibitor film. It's clear that in the presence of the inhibitor, current density values decreases substantially. The electrochemical parameters were presented in this table. The data revealed that the potential of corrosion shifted towards less negative values as the concentration of the molecule increases. This shift suggests selective inhibition of the anodic reaction, particularly metal oxidation. Also, all the results confirms that the inhibitor acts as a mixed type inhibitor with a stronger influence on the anodic reactions. The current density values decrease significantly with increasing inhibitor concentration, resulting in a corresponding increase in inhibition efficiency. So at a concentration of 10-2, an inhibition efficiency of 92.02. Let's move to the electrochemical impedance spectroscopy. So electrochemical impedance spectroscopy is a powerful and reliable electrochemical technique used to extract more information about the mechanism that take place at the branch interface. As we can see, Nikkei's plots exhibited two capacitive loops. So the diameter of the semicircles rise with the increase of the concentration of the inhibitor. This indicates the ability of the inhibitor to act at the electrolyte surface interface and generate a branch surface protection. So the inhibition efficiency reaches a maximum of 91.88% at a concentration of 10-2, which is the line with the results of polarization curve and gravimetric tests. Adsorption is also a valuable tool that lets us to know the nature of the interaction between the inhibitor and the surface of branch in the sodium chloride medium. So the results indicate that we have both physisorption and chemisorption. To confirm the results obtained previously, qualitative microscopic analysis of SEM were performed. The surface states of branch samples after 24 hours of immersion in saline solution is strongly damaged by the medium and covered by corrosion products, so the corresponding EDX spectra detects the appearance of a high oxygen contents of this sample, as well as peaks of the atoms of chlorine. So this may indicate the presence of oxides species over the surface. However, in the presence of the inhibitor, the attack is notably improved and protected, which confirms the formation of an inhibitor layer, whereas the EDS spectrum shows the decrease in oxygen peak, the disappearance of chlorine peak, and the increase in the carbon peak, copper peak. So this undoubtedly indicates the presence of the inhibitor molecules on the surface that block its damage and preclude the formation of corrosion compounds through its strong adsorption on the surface. So to conclude, this research demonstrated the promising potential of 1,2,4-tyrosol derivative as an effective corrosion inhibitor for bronze B66 in the presence of aggressive ions within a saline environment. The inhibitor efficiency achieved 92% at a concentration of 10 to the -2. So the results are encouraging, highlighting the use of the triazole derivative for mitigating the corrosion of bronze in aerated sodium chloride solution. And thank you for your attention.
Thank you for your presentation. If there's any questions? No, thank you again. With this presentation, we finish part 2 of section 3. I want to thank all of the participants online and offline, and I want to say thank you, especially my colleague who helped me to present this section, Mr. Cristian Signon. Thank you.
I thank you also, Ms. Morcioiu. Thank you very much for this opportunity.
And now will be a short break, coffee break, 10 minutes, but before
the break, as you probably know, we have to announce once again the sponsors. I start with the Ministry of Education and Research, the European Technology Platform on Sustainable Mineral Resources, who is also the co-organizer of our event. And finally, the two Romanian companies, Altium and Nanoteam. We thank all of them for their support, and we thank you for the attention in the frame of this third section.
Thank you.
Enjoy your coffee. Thank you.
Nu. Scuze. Secțiunea 4 suntem noi. A doua zi. Suntem pe ambele zi. 4 și 5. Da. Mă duc și eu să socializez acolo cu Florinela, cu cine mai este. Mergi pauză de cafea. Chestia e că anul trecut ea a fost, că asta este
Hello. Hello to everybody. So we'll continue our conference with section 4, materials modeling and simulation. So we are a bit late with our section, but maybe we'll be in time, we'll end in time. So the first speaker is Mrs. Elena Ionela Kerekeș from Institute of Macromolecular Chemistry, Petru Poni from Iași.
Hello. I share my presentation now. Can you see my presentation?
Yes, can you put it on full screen?
Yes, one moment. It's okay?
Yes, you can.
Okay, my name is Elena Ionela Kerekeș. I'm from Technical University Gheorghe Asache of Iași, Faculty of Material Science and Engineering. And today I will present the paper Surfactants for Stable Nanocolloids, an experimental approach. Okay. Nanofluids development, it's relevant for a lot of applications due to their excellent results in heat transfer. However, to successfully implement these fluids in real-life application, their drawbacks have to be studied in detail. An important factor are the cost. Nanoparticles used in nanofluids can be expensive, which increases the overall cost of producing nanofluids. Also, the stability is another important factor. Maintaining the stability of nanofluids can be challenging due to the tendency of nanoparticles to agglomerate, reducing their effectiveness. Toxicity, depending on the nanoparticle used, there may be concerns about toxicity to humans and the environment, especially during production and disposal. Thermal conductivity saturation. The increase in thermal conductivity of nanofluids may saturate the higher nanoparticle concentration, limiting the future enhancement benefits. One of the main disadvantages of nanofluids is the low stability combined with sedimentation. Over the years, a number of researchers employed surfactants to overcome this problem. However, the studies did not relieve any useful information to create an outstanding protocol. The table below presents the main types of surfactants classified according to their electrical charge and chemical structure, along with the representative examples for each category. Materials and methods. This article provides several experimental insights into a number of surfactants and their influence on thermophysical properties, trying to shed some light on their influence of nanofluids. The experimental was developed by employing distilled water and titanium dioxide nanoparticles and by selecting a number of surfactants. In addition to the surfactants, 2 polyethylene glycols with low molecular mass were studied as surfactants. In the table are presented the surfactant name with the chemical formula and with density and molar mass. Results in discussion. The thermal conductivity, isobaric heat capacity, and diffusivity were experimentally measured at ambient temperature, and it was noticed a decrease in thermal conductivity when even little quantities of surfactants are added. The surfactants concentration varied from 2 to 6% mass concentration for all samples, while titanium dioxide nanoparticles concentration was 2% mass concentration for all the samples. The nanofluid was prepared by two-step method. This means the nanoparticle was dispersing in base fluid with ultrasonication. In the table also are presented as sample code used in the next slides. Results and discussion about thermal conductivity. The addition of the surfactants, even in low percentage, lowers the thermal conductivity of water by at least 1%, going up to 4.5 for PEC 200.
The phenomenon that appears it's a logical one, based on also on the rules of the mixture due to the low thermal conductivity of almost all surfactants, if compared with that of distillated water. Also in the figure present the experimental setup used for thermal conductivity measurements. Results and discussion about isobaric heat capacity. The surfactant addition influences the properties of distillated water, while the PSS addition has the lesser influence. PEC 200 reduces the isobaric heat capacity of water by 2% in concentration of up to 6% mass concentration. The surfactant addition, even if can increase the suspension stability, it reduces the thermal properties, and this is a disadvantage. Another major drawback is the foam that appears when several surfactants are employed, especially SDBS. SDBS is one of the most polar surfactants, but the foam appearance is decreasing its instability in a lot of applications. Results and discussion about thermal conductivity. Data on thermal properties of nanofluids with titanium dioxide and surfactants revealed that the addition of nanoparticle increased the heat transfer capacity of the fluid by 7.2%, while the addition of surfactants lowers this increase. Reasonable results are attained for small concentration of surfactants. The main conclusion that arises from this experimental study can be summarized as: the surfactant addition lowers the thermal conductivity of water and nanofluids. SDBS, due to excessive foam creation, cannot be employed in applications that are involving turbulence or tube heat exchange. PECs can be a solution for improving the stability of nanofluids, and also the addition of surfactants in nanofluids with titanium dioxide decrease the thermal conductivity of the nanofluid itself. Thank you very much for your attention.
Questions? There are questions online?
No.
Thank you again. One.
Ciprian.
Okay, the next presentation from section 4 will be done by Diana Constantin from Astronomical Institute of the Romanian Academy. The title, The Pulsatory Liposome Functions as a Perceptron. Mrs. Diana, please, you have the floor.
Thank you a lot, Mr. Bitticescu.
I don't know which one. Which one is the folder?
Depinde.
Așa.
Și timpi.
Asta?
Da.
Ok, imediat.
Dragii mei, mă bucur că ne revedem în ocazia plăcută a conferinței EMERGEMAT ediția 8. Și aș dori să vă cer îngăduința de a mă exprima în limba noastră, căci ar fi mult mai ușor pentru mulți din noi. Cred că aici în sală suntem toți români, iar prietenii noștri online ne pot contacta pe mail. O cale pe care am bătut și ani de zile cu colaboratorii din exterior. Mulțumesc pentru ocazia de a fi la această conferință și mă bucur că ne revedem. Prima lucrare se referă la două concepte interesante. Unul este lipozomul pulsatoriu și în această prezentare vedem cum poate fi simulat via o rețea neuronală de neuroni artificiali. Colega mea, frumos. Echipa noastră e formată din, eu sunt astronom, Diana Radnet Constantin, colegii noștri la aveți aici pe domnul Valentin Niculescu de la fizică și colegul nostru
specializat pe biofizică, Dumitru Popescu, și o colegă tot de asemenea de la fizică, doamna Bucanu. Da, mai departe. Ce e lipozomul? Trecem rapid peste acest subiect, întrucât am prezentat ceva și anul trecut. Este o membrană artificială care ne ajută să înțelegem mai bine cum funcționează membrana celulară. Aici avem un lipozom unilamelar, întrucât avem un singur strat care separă mediul interior de cel exterior. Este introdus într-o soluție apoasă și mediul din interior este osmotic, în sensul că doar apa traversează membrana lipozomului, de fapt lipozomul, și mediul din exterior este hipotonic, în sensul că există un gradient de concentrație între mediul interior și cel exterior, cel interior având concentrație mai mare. Da. Aici avem cum îi zice, o ilustrare luată de pe Wikipedia pentru lipozom. Se poate vedea mult mai ușor stratul unilamelar realizat pe baza moleculelor fotolipidice. Aici avem capul polar, polară formată din carbon și hidrogen, atom de carbon și hidrogen, catene de carbon. Pe dinăuntru, în imaginea de față, avem ca solvit nutrienți. Da? Acum vorbim un pic despre despre mecanismele prinse în derularea unui ciclu arbitrar din cadrul evoluției lipozomului. După cum observați, lipozomul este pulsatoriu. De ce e pulsatoriu? Întrucât pentru o concentrație de pornire C0, în funcție de acest C0 avem un număr de cicluri în care acest lipozom, vom vedea în primul stadiu al unui ciclu, lipozomul pleacă de la o rază de ordinul până în 20 de microni, crește până la o rază un pic peste 20 de microni, după care intră pe celelalte două faze, step 2 and step 3, intră pe faza de descreștere a razei lipozomului, numai că, interesant, această creștere a razei lipozomului e oprită de apariția unui por, care, la faza a doua, apare cu o rază observabilă de tipul 2 microni, evoluează până la sfârșitul fazei 2, până la o rază jumătate din raza lipozomului, deci acest por, iar în faza a treia, când suntem în continuare pe descreșterea razei lipozomului, acest por la rândul lui descrește până a dispărea. Și aceste trei etape descriu, cum am spus, un ciclu oarecare din evoluția lipozomului. Aici avem schematic cele trei faze, de creștere orizontală, apoi descreșterea lipozomului, fazele 2 și 3, cu apariția porului, care, observați, în faza aceasta ajunge la o rază aproape jumătate din raza lipozomului, după care dispare. Ce e interesant, lipozomul, după cum vedeți în schemă, pleacă de la o rază R mare 0 și revine la aceeași rază, ceea ce exprimă elasticitatea acestei membrane. Mai departe, te rog. Aici avem următorul slide. În acest slide avem legile de compoziție ale lipozomului, și anume ecuația care descrie raza lipozomului, funcția R mare de T, după aceea raza porului și concentrația. Bineînțeles, tot aici puteți vedea câteva constante de material, spre exemplu, elasticitate mare, viscozități. Bun, și ceva parametri de intrare, cum sunt mare 0, ermic 0. Revin asta doar de Pentru prima fază, când lipozomul crește în rază, acea ecuație pentru R mare se poate rezolva analitic și soluția aveți scrisă în această expresie implicită, pentru care putem extrage timpul, de exemplu. Spre exemplu, pe simularea noastră, pentru un C0 de tipul 11 mol pe metru cub, obținem un timp de ordinul 1470 și un pic de secunde, ca ordine de mărime. Bine, aici avem câțiva parametri de model pe care nu vreau să insist acum. Mergem mai departe. Și, cum v-am promis, în lucrarea de față, simulăm, încercăm să simulăm, propunem simularea evoluției lipozomului cu ajutorul unei rețele neuronale. Doresc să înțelegeți bine ce se întâmplă în cadrul unui ciclu arbitrar kappa, și anume ce vreau să subliniez. Orice ciclu începe printr-o valoare de pornire a concentrației și, natural, o valoare finală a concentrației. În articolele noastre anterioare am arătat că, după cum de altfel și vă așteptați, concentrația pleacă de la o valoare și scade în timpul celor 3 faze. Bun, următorul. Și acum conceptul de rețea neuronală. Deci un grup de neuroni artificiali care în fapt pot fi PC-uri sau detectori, ne creează acest concept de perceptron. În cazul nostru, perceptronul pe care îl propunem este de 2 straturi, pe lângă stratul de intrare și cel de ieșire a datelor. Deci, în afara celor straturilor marginale, să zic așa, de intrare și de ieșire a straturilor, straturile intermediale dau numărul de straturi pentru perceptronul. Da. În cazul nostru, perceptronul este format din primul rând de neuroni și atrag atenția, informația întotdeauna lucrează doar într-o singură direcție. Primul strat e format din neuroni care se ocupă de funcția de model R mare, adică raza lipozomului, stratul al doilea de concentrație, stratul 3 de raza porului și stratul 4 se referă la constantele fizice. Acum, odată ce simulăm un ciclu arbitrar kappa, întotdeauna introducem raza R mare a lipozomului, care, am spus, este cu acuratețe dată valoarea 19,6 microni, concentrația inițială de la primul ciclu, am zis, pornim cu el în simularea noastră, 11 mol pe metru cub. Raza porului, în prima fază nu există por, deci raza e 0, ermicul, dar când ajunge la o valoare observabilă de tipul 1,56 microni, o să vedem, intrăm pe fazele 2 și 3. Și acum descriem un pic layerele, straturile intermediare. Spre exemplu, primul strat reușește să furnizeze, după prima fază, raza la care ajunge lipozomul, raza maximă, 20,6 microni, concentrația, iată și raza porului, acele mici R0 în jur de 2 microni. După aceea se intră în faza de dezvoltare a porului, când în prima etapă crește și în stratul acesta de neuroni sunt salvate și furnizate valorile pentru parametri R mare, C mare, R, când porul ajunge la valoare maximă, iar la final acest perceptron ne furnizează informații referitoare la, și cum am subliniat, la concentrația mediului interior după parcurgerea unui ciclu și alți parametri ai modelului, dar în primul rând concentrația. Această structură de rețea neuronală numit perceptron are ca în esență aspectul definit de apariția feedback-ului, care constă în concentrația finală pe un ciclu devine concentrație inițială pe următorul ciclu. Și, spre exemplu, pentru un C0 de tipul celui menționat, valorii menționate 11 mol pe metru cub, obținem ca număr de cicluri un N de ordinul 20 de cicluri. Bun, mai departe, te rog. Aici avem o reprezentare grafică cu evoluția concentrației de-a lungul ciclurilor, 1, 2, până la, și cum am spus, pentru valoarea 11 pe concentrație obținem ca număr de cicluri în 20. Bun, în slide-ul acesta sunt spuse pe scurt, menționate pe scurt, datele de intrare, deci C0, R mare 0, RC-ul, raza maximă la care ajunge lipozomul după prima fază, R0 mic la sfârșitul primei faze, când apare porul și este vizibil, iar ca dată de ieșire, timpii pe fiecare fază, timpii, și cum v-am spus, pentru concentrația 11, timpii sunt pentru prima fază 1400 ceva de secunde, iar fazele 2 și 3 net, mult mai scurte, de ordinul 2-3 secunde. Bun. Și, ca și concluzie, numărul de perceptroni este egal cu numărul de cicluri pentru în evoluția lipozomului nostru pulsatoriu. Ca și concluzie, evoluția lipozomului pulsatoriu constă în această diferență de concentrații între mediul interior și cel exterior. O aplicație extrem de interesantă este aceea în care pe interior introducem tot felul de substanțe speciale, că putem dopa cu ioni de un anumit fel, și problema rămâne cum amplasăm acest lipozom unde în organism și cum să se realizeze transferul, sau că introducem o soluție farmaceutică și întrucât cunoaștem evoluția, avem soluții pentru calcularea timpilor de eliminare a substanței în mod controlat. Deci lucrurile acestea produc avantaje de a utiliza lipozomul pulsatoriu în diferite maniere. Mai jos am adăugat o frază care face legătură cu faptul că lucrez în astronomie și ne gândim să extrapolăm mecanismul de apariție a corului și în zona astrobiologiei. Mulțumesc, ăsta a fost primul studiu. Of course, if someone asks.
There are questions?
Thank you very much. Questions, please.
O curiozitate, nu cunosc foarte bine domeniul, dar deci concentrația inițială C0 nu ar trebui să fie cât de cât apropiată de concentrația finală pe ciclu?
Păi,
sau nu știu dacă ați făcut un
ciclu. Care ciclu?
În primul ciclu. Noi plecăm de la ciclu C0.
Pentru primul ciclu, spre exemplu, deci pornind cu 11 ajungi la 8,7. Dar descrește conform slide-ului în care te rog frumos mai dă un pic. Așa, da, observi.
Și o descriere concentrație de
Da. Și asta e după 20 de cicluri. Da. În fine, când am studiat soluțiile analitice, am încercat să obținem și condiția de oprire pentru concentrații, da? La ani. Urmă.
Da.
The next presentation, quantum spectral model and the hydrogen spectrum.
Bă, da, că asta e aia. Nu. Ia celălalt. Scrie poster. Da, spus. E bun. Excuse me. Here. Mă scuzați, acum shiftăm în alt domeniu, și anume cel al spectroscopiei. Ca astronom, nu mai trebuie să motivez de ce e un domeniu extrem de important. Analiza datelor spectrale. Avem o serie de volumi imense de date spectrale de astrofizică. Lucrarea de față doar arată cum, la un moment dat, producând un model cuantic spectral, îl validăm, calculând o linie a hidrogenului și după aceea ne comparăm rezultatele estimate statistic, după cum veți vedea în lucrarea de față, dar via un model teoretic spectral și facem apel la date și din astrofizică. Deci, o linie a hidrogenului, cramida, și o să vedeți la referință primul articol, este cel al domnului Cramida, are o lucrare de referință în care subliniază, poate pentru unii sună trivial, dar din aspect extrem de important, sunt enorm de multe date în spectroscopie, dar e nevoie, pe lângă datele experimentale, de crearea de modele teoretice ca să explice fenomene de finețe. Ăsta e un aspect. Al doilea aspect este acela că, da, toate spectrele elementelor chimice din tabelul lui Mendeleev se bazează pe înțelegerea spectrului hidrogenului. De altfel știm și în modelarea orbitalilor atomici că orbitalii celorlalte elemente chimice, specii chimice, pleacă de la variații mici în jurul modelului pentru orbitalii hidrogenului. Draga mea, te rog, mai departe. În lucrarea de față, cum am spus, ne bazăm pe modelul cuantic al atomului de hidrogen. Calculăm și tabulăm picurile, liniile spectrale din multipletul alfa Humphrey, adică seria 6, seria Humphrey a hidrogenului, prima linie alfa, și anume acest multiplet, adică grup de linii spectrale văzut în structură fină, în aproximația structurii fine. Determinăm via modelul spectral numit Maximum Localization Spectral Model, bazându-ne pe o serie de ipoteze spectrale și ipoteze statistice. Prin analiza statistică realizată pe datele de la NIST și datele solare de la baza, din cadrul bazei ACE, evaluăm curbele de regresie pentru multipleții de la prima serie spectrală Lyman până la A6 inclusiv și pe final reușim să realizăm o vedere globală a primelor 6 serii spectrale și, după cum v-am spus, dăm și valori numerice pe care le comparăm atât cu ce furnizează NIST-ul și NIST-ul furnizează pentru Humphrey alfa, întrucât este în zona de agitație moleculară, furnizează lungimea de undă în aproximația Bohr nu poate, deocamdată, nu sunt date cu rezoluție bună pentru a vedea multipletul în structură fină. Ăsta a fost motivul pentru care, în plus, motivul pentru care am dorit modelul nostru spectral să-l validăm pe linia Humphrey-Alpha. Mai departe, te rog. Bun, să trecem un pic în revistă modelul nostru spectral. Aici aveți o dată culeasă de la NIST pentru linia alfa, deci a 5-a serie din Humphrey, seria fund, linia alfa, prima linie. Ea se vede o linie în aproximația Bohr, în aproximația structurii fine. Observați această pajiște de fire de iarbă. Prima dată am avut senzația asta când am văzut. Modelul nostru ajută în identificarea, înțelegerea mai bună a structurii spectrale în structură fină și anume propunem în lucrările anterioare, am definit ce sunt acelea stări cuantice de maximă localizare și acest picul cel mai înalt am explicat că este generat de tranziția pentru linia aceasta, cum v-a zis, alfa, pentru tranziția între stările de maximă localizare 5, 4, 6, 5, unde în paranteză avem pe primul loc N-ul, adică numărul cuantic principal, al doilea numărul cuantic orbital N, care variază de la 0 la N-1, în cazul nostru de la 0 la 4, fiind vorba de stare cuantică de maximă localizare, e pentru L egal cu N-1. Bun. Și acum, pentru a vă explica și procedeul de construire a multipletului Humphrey-Alpha, profit de ocazie și odată ce ne-am fixat picul ML pentru o linie anume, pasul următor este să identificăm începutul multipletului și anume picul de ordin de tip 0. Și să observăm via modelul nostru că fiecare multiplet dintr-o serie N conține nici mai mult, nici mai puțin decât N picuri reprezentative. De ce reprezentative? Pentru că fiecare pic indicat aici în imagine este reprezentativ pentru un grup de liniuțe mai fine ilustrate cum se află tranzițiile pentru aceste sublinii dintr-un grup. Prin regula spectrală delta L 0, iar pentru cele mari pentru delta L 1. Bun, mai departe. Cum am spus, pe lângă ipotezele spectrale din modelul nostru, utilizăm și ipoteze statistice. De ce? Pentru că scopul nostru e de a construi acest alfa multiplet în structură fină și întrucât ne bazăm pe datele Humphrey-Alpha, am zis că e prima linie din seria 6, ne bazăm pe datele spectrale existente în baza NIST pentru seriile anterioare. Și întrucât dispunem de aceste date spectrale pe seriile anterioare, ne-am gândit să facem o estimare bazându-ne pe statistică și anume pe metoda de regresie și folosim metoda de regresie de tip hiperbolic. O să vedeți pentru ce anume în imaginea. Observați acești curenți, numiți de noi curenți spectrali, care pleacă undeva din vecinătatea lambda 0 și urcă. O să ziceți unde e lambda, vă spun imediat. Dar vreau să observați acest concept de curent spectral obținut de înapoi, te rog, via metoda de regresie hiperbolică. După aceea, anterior. Observați, multipletul are picurile, și acum trebuie să vă spun ce am realizat în plus în acest model. N-am lucrat neapărat pe spectru plotat, adică intensitate via lambda, ci am scalat de 2 ori și am lucrat într-un spațiu, da, dă-i mai departe, așa, într-un spațiu UUZZ, unde am dublă scalare pe lambda și dublă scalare pe intensitate. De ce? Vă spun la sfârșit de ce. Așa, revină. Da. Deci, încă o dată. Deci, observăm că pentru distribuția picurilor pe multiplet se pot utiliza tot tipul de distribuții în statistică. Eu însă lucrând cu distribuție beta, numai că pur și simplu am avut senzația că omor musca cu tunul, adică folosesc un instrument prea puternic, prea complicat. Aș putea să lucrez, de exemplu, în regresia de tip liniar, pe conceptul de scattering line. Nu am aici nici timpul. Lucrarea când ne va apărea va da detalii de ce am ales până la urmă distribuția picurilor în multiple de tip liniar, dar mai departe. Și un alt tip de regresie utilizat este cel de polinom de gradul 4. Așa. Când v-am spus că în momentul când reflectezi asupra unui multiplet în structură, în baza NIST, important este să identifici picul de maximă localizare și primul pic, cel de ordin 0, ca să ai un parametru extrem de util pentru noi, și anume lărgimea multipletului. Și întrucât aveam aceste valori pentru lărgimea multipletului pe datele din seriile anterioare, am ales să extrapolăm pentru seria 6 cu acest polinom de ordin 4. Bun. Rezultate deja. Mă credeți pe cuvânt, după ce scalăm de 2 ori coordonata lungimii de undă, va acoperi acest interval, așa că nu vă speriați că nu vedeți Armstrong și Limanul de la 1024, etc. În această reprezentare grafică, aici undeva se găsește linia alfa, Lyman, Balmer, alfa Balmer, alfa Paschen, alfa bracket, alfa fundul. Deci aici e zona de date pe care le aveam extrase din baza NIST. Și picul ML, via articolele noastre anterioare, pentru linia Humphrey alfa. Mai departe. Bun. După ce am obținut via regresie hiperbolică acele curente spectrale și am obținut distribuția pentru multipletul Humphrey alfa, iată rezultatele. Deci picul ML în zona aceasta, 123,705, o valoare importantă, pentru că pe ea voi face discuția când mă refer la ce furnizează NIST-ul și ce furnizează ACE-ul, baza de date ACE. Și aceste picuri construite în lucrarea noastră pe baza procedurii intersecția curenților spectrali, intersecția lor cu distribuția multipletului în cauză, care ne furnizează, atenție, doar picurile de la 0 până la n-2. De ce? Pentru că noi acești curenți spectrali îi obținem via regresie, adică date existente. Pentru picul de aici, penultimul, nu avem decât o singură dată, deci nu putem face regresii. Și acolo, în momentul acesta, în modelul nostru cuantic spectral, intervine o a doua ipoteză spectrală, și anume, linia spectrală în aproximația Bohr are ca intensitate suma liniilor spectrale din structura fină. Asta este ipoteza a doua modelului și via această ipoteză am putut identifica penultimul pic. Bun. Cum îl vedeți în imaginea de față, multipletul nostru ocupă zona din spectru, o să mă refer la ultimele două cifre, 123, imediat închei, 702,7, 705,1, ACE-ul furnizează 710 și NIST-ul 719. Noi când am obținut mărimile estimate, s-a întâmplat că lucram și pe date solare și o întrebare acolo fusese această valoare pentru linia Humphrey-Alphan ACE de 123.710 față de NIST 719. Și iată rezultatele noastre de estimare statistică au venit în a explica diferența între ACE și NIST. Bun. În sfârșit, v-am spus utilitatea scalării coordonatelor lambda și I, pentru că asta ne-a ajutat să realizăm această imagine globală în care vedem aici zona serii Riemann, Palmer, Paschen, bracket și Humphrey. Humphrey alfa fiind prima linie din seria Humphrey. Mulțumesc!
Questions? Line?
Okay. Thank you very much also for this interesting presentations. The next presentation will be impact of the thermal relaxation time on generalized bioheat equation, a comparative study of analytical and numerical models will be done by Mrs. Alexandra Trefilov from National Institute for Laser, Plasma and Radiation Physics.
Hello, thank you. I'm very happy to be here at your conference. Did you put already the presentation on the slide? I'm not seeing the slides. This is why I'm asking. Can you hear me?
We have the share to share.
Should we share or you share?
Okay, then I'm waiting for you to share it.
Okay.
Should I share it?
If you can share, but if you want us to share it, we can share it. How do you want?
Share it.
Okay, we will share.
Today I'm presenting the impact of thermal relaxation time on generalized bioheat equation, a comparative study of analytical and numerical models. Next slide, please. Then I'm going to present a general overview of the presentations, followed by the abstract, as it's seen in the overview. Can you go to the abstract, please? Thank you very much. The Pennett's bioheat equation is a widely used model for describing heat transfer in living tissue during thermal exposure. Derived from the classical Fourier law, it assumes energy exchange between blood vessels and surrounding tissue. While many numerical methods exist for solving it, analytical models are rarely reported. This study develops a three-dimensional analytical model using a non-Fourier model using mathematical validation through COMSOL simulation to describe laser-induced heat transfer in biological tissue under therapeutic conditions. To improve the classical bioheat equation, three key enhancements are introduced: a non-Fourier framework that includes thermal relaxation time, the use of Dirac functions, and the telegraph equation to simulate localized point heating, and a closed-form analytical solution for both the classical and extended models. The relationship between the telegraph equations relaxation parameters and the bioheat model's thermal response is explored in detail in these presentations. The generalized models offer a more realistic view of heat exchange between tissue and blood flow, accounting for a non-uniform temperature distribution. A strong agreement was found between analytical, the mathematical, and the numerical constant results, supporting the model's accuracy. Overall, the research supports the development of more precise laser burst treatments and thermal therapies, helping to improve the clinical outcomes. Go to slide 4, please, which represents the constitutive equation, the mathematical formula, please. The classical Pennes equation serves as the foundation of the thermal model. To represent the precise and instantaneous delivery of laser energy, the Dirac functions is used. In parallel, the telegraph equations introduces a finite time delay in heat conductions, accounting for the thermal relaxation time and allowing wave-like heat propagation. Together, those components create a realistic framework for modeling heat transfer during laser tissue interactions, especially in cases involving ultra-fast or highly localized energy input. Go to the next slide, which represents the second part of the equations. When the heat source is expressed via derived delta functions, which you see in the first equation presented, the Zukovsky equation, and then you also we introduce the Zukovsky equation, which admit closed-form analytical solutions, offering a powerful tool for deriving precise temperature fields and validating numerical models. This is the complete form when the Zukovsky equation was introduced, is the second part of the equation. Okay, the next slide represents the physical parameters employed in the computational analysis. You can go to the next slide, please. Thank you. This slide presents the simulation temperature distribution. The key differences between the simulation are presented in the table in the right part. The computational domain is set in a rectangular coordinate system with the heat source placed at the origin. The spatial coordinates x, y, and z represent position on the surface of the diseased tissue. The x-axis shows the direction of laser propagation, while the y and the z-axis are perpendicular to it. This setup helps accurately model how heat spreads and how thermal waves move through biological tissue. So in figure 1, FA, you see the analytical formula derived from the classical Pennes equation. So in this case, the thermal relaxation time is 0, as is seen in the table. When the laser beam hits the tissue, the temperature rises instantly at the focal point. Because the classical model assumes infinite heat propagation speed, heat spreads immediately across the domain. This creates a sharp temperature gradient at the point of laser contact, with high temperature reaching nearby tissue layers up to 7 millimeters away. The temperature stays elevated for about 30 seconds before gradually returning to the baseline of 40 degrees Celsius. We started the simulation at 40 degrees.